Hi, and welcome to this Teacher's Programming Procedure video by MyBot. If you are a student, let your teacher know this is directed towards them, and if you're a teacher, let's get started. The first thing you need to do is go to your MyBot interface, and you can use your MyBot Basics document to find out how to do so. From there, launch Blockly. First thing we need to do is name our file. So click Save, and then type in Morse-code version 1 and click OK. Throughout this video, I'm going to give you suggestions on how you can lead your class to doing this program. Now, the way this lesson plan is set up, you will be the one programming, but it's important that you help guide your students through the logic and methodology used to create a code. In this particular activity, what you're hoping to do is create a program that will tell your robot to drive down a straight line, and anytime it passes over black, it will turn the light on. That way you can translate coded with paper, Morse code, into a light system. Start by asking your students, what do we want the robot to do? Hopefully you'll get some feedback of, well, we want it to drive, we want it to turn the light on, things like this, so you can then respond with, let's start by telling it to drive. To you, go into the motors then, and add a drive at speed command. To add any commands to your scene, simply click on them, and then drop to connect to the bottom of your code. You'll notice it sort of clicks into place. Next, ask your students, okay, how fast should our robot drive? Do you want it to go fast or slow? Let them be a part of this process. For our code, I'm just going to type in 30, but you can select any value between 0 and 100 because this is actually controlling the power of the motor as a percentage. Next, ask your students, well, what else do we want the robot to do? We have it driving, but what else would come next? And this is where they should hopefully answer that they need it to turn the light on and off at certain points. So then you can follow up with, well, when do we want it to turn the light on? Okay, so if the robot is traveling over a black section, then we want to turn the light on. And when you're saying this, really focus on emphasizing the if-then, because that's how you write the code. So if the robot is over black, then we want it to do this. We want it to turn the light on. So to do that, you're going to find that in logic. So go into your logic menu and grab the top option, which is an if-do command. The next question to prompt your students with is, so how can the robot know when it drives over black? Does it have any tools it can use? Students will get a chance to brainstorm a little bit here, and then you can, summarize hopefully what they've come up with and let them know that the robot has a sensor we can use to tell how dark or light something is. And then let them know that a big number means it's over white, and a small number means it's over black. If you know this, how would you program the robot to know when it's over black? Hopefully the students will give you some sort of feedback that you might need to compare it to a number, and then if it's a small number, it can do something. Well, let me add a comparison command. And you can find that comparison command in the logic menu. It's the second option down here, and it has the two blanks on either side of an equal sign. Drop it onto the end of the if portion of your command. So ask them then, well, what should we put in our comparison? Hopefully you'll get the feedback of you should put something related to the sensor and a number. So when you get that, you're like, all right, well, I'll go grab the correct sensor. And you can find the sensors in the sensor menu, and this one's going to use the optical distance sensor. And then there's just one option, and bring it into the first half of your if command. This is a good chance now to review with your students. Since we want the light to turn on when the sensor is over black, do we want the reading on the sensor to be smaller or larger than the number when the light should be turned on? Now remember, the sensor gives us a big number when it's over white. They'll have to think about this, and you might have to repeat it a couple times because this is pretty complex. It would probably help to write like black, white, big, small. Keep notes on the board as you're doing this activity so the students can have visual reminders of what they've learned throughout. Since we want a comparison to look for a smaller number, because we want it to be black, then we're going to go in and use this drop-down menu and select less than. What are we comparing this to? A number? Right. You can then go in and grab a number from the math menu, and it's just this top option. So grab the value, drop it in, and you can just type in the number that works. Now, I'm putting mine at 800. You might have to adjust yours slightly, but that's a good starting point. I would suggest you figure this out in advance of doing this activity with your students so you know what number works for you. All right, after this, congratulate the students. That was really complicated right there. So now that we've told the robot to figure out when it's over black, what do we want it to do when it is? What do we want it to do when this is true? Students should be able to very quickly answer that they want the light to turn on. Great. You can have two options, and you find them both in the Fusion control menu. Let the students pick whether they're turning on the yellow or the blue LED light. Grab one and bring it into the Do section, because it's saying if this is true, if you can tell you're over black, then turn on the light. So you have the first part of your command. Follow this up with another question. What do we want the robot to do when it's not over black? Okay, so if it's over black, you turn the light on. Else, or otherwise, turn the light off, right? So in order to do this, tell your students you're going to add an else command. And you can get to that by clicking on this little gear here next to the if, and that'll open up the settings. When you do that, just grab the else and drag it onto the bottom of the if. When you do that, you now have an else section on your code. Click the gear again to close it. Now that we have a place for an else, what do we put in it? Remember, this is the line that tells the robot what to do when it's not over black. You can either copy and paste it, or you can go back into Fusion Control and grab a new one. But bring another LED command into this else, and then in the drop-down menu, switch it to off. At this point, have your students click play, run the program, see what happens. Then ask them some follow-up questions. Did it do what you expected? Why do you think it behaved the way it did? And so forth. Prompt that discussion. And then, why didn't it keep driving? How do you think we can fix that? That's right, we can tell it to repeat what it's doing. So to add a repeat command, you'll find that in loops. And then grab a repeat while true, which is that top option. And this one you want to drag onto the top of your code. So that's right below the Fusion start block. Then you simply can click on where it says drive at speed, and that will grab all of the code starting at that line and under, and you can drag it inside your loop. Bring it into your repeat command. Now you want to give the students just a little bit of background. Anytime we tell a program to repeat something, we have to tell it how often to do so. Some students may be like, every couple seconds, but especially if you're driving quickly, you're gonna need to check it a lot, like multiple times each second. And once you come to an answer here, you can grab that command by going into the time menu and adding a wait. Now bring this one just below your else command, so it's the last thing in your repeat. And then type in 0.1 to have it go every 10th of a second. And that's it. You now have a functional code that will turn the LEDs on anytime the robot drives over black. That way you can have it drive over physically programmed Morse code papers and flash with dots and dashes.